Is the agenda for today. We're going to talk about the CS45, the 2.5 watt BDA. We've had the CS45 half watt BDA for over a year, and this is the new 2.5 watt. And we're going to talk about its size and weight, what's inside of it, the mechanical layout of the thing, some electrical specifications and RF specifications and features. And we'll also talk about its associated battery backup unit. It has a battery backup unit that is unique to this product. The battery backup unit that is used for the half watt is different than the one for the 2.5 watt. So we'll talk about that. And we'll give a brief overview of the graphical user interface, the GUI. And one of the things that's pretty exciting about this product is it can be a standalone BDA, or it can be converted into a fiber DAS master. So we'll learn all about that. And then we'll talk about the kits, how you can just use one part number and get not only the BDA, but also the battery backup unit and the batteries. And so we'll have that ordering information near the end of this presentation. And as we already mentioned, if you have any questions, go ahead and type them in. Microphones will be muted, so typing is the only way to ask a question, and feel free to ask anything you want. So this is available now, the BDA, the 2.5 watt. And the very first slide that I'm showing you about this is maybe a little bit of a surprise. I'm not showing you all the features and all the things that it can do. I'm showing you the size and the weight. Because in reality, this is one of the main selling features of the CS45 line of BDAs. They are small and light. This one is 26 pounds, which is easily half the weight of most 2.5 or 2 watt BDAs out there. We have people just taking this out of the box. They hold it up on the wall with one hand, and they mark where the mounting holes are going to be with their other hand, and it's a one-person job. It's very, very nice in the field. Let's talk about the mechanical aspects of it. Of course, it is NEMA 4, as it must be to meet the code IP65. It is UL 2524 listed, which of course it has to be as well, and FCC approved. That's almost always a given. We got 4 liquid-tight conduit fittings on the bottom. 3 of them are 3/4, one of them is a 1/2 inch. And that is for our fiber DAS connection, our BBU connection, and the alarms to the fire alarm control panel monitor modules. And if you need a remote annunciator, we have a conduit for that. At the top of the unit, can't really see it here, but we have 2 N-type female RF ports on the top for donor and service antennas. And right beside the remote annunciator conduit port is our GUI, our graphical user interface. That's an RJ45 commissioning port. And internally, we have compression screw terminals for the alarming that go to the monitor modules. It's a wall mount. The ears are on the unit when you get it from the factory. And it does have 2 locks, of which one of them is lockable. And as you can see, we have a built-in alarm annunciator on the front panel. It covers all the current alarms, including oscillation detection, which is an IFC 510 requirement. And from what I'm told, the next edition of NFPA 1225 will also require oscillation detection. So there we are. And if someone invents even more alarms that we can't even think about right now, we have a Custom 1 and Custom 2, which we can activate with a firmware update once someone defines what new alarm someone might want. So it's very future friendly. Looking inside the unit, over on the lid, that is the annunciator driver board. And there's a little buzzer there, so when there's an alarm, you get an audible alarm. That's where it comes from. We have the interface module. Anything that gets connected to the outside world gets connected there, such as the fire alarm control panel, the battery backup unit. a emergency power off, which is actually emergency transmit disable, the local graphical user interface, and also if you need to remotely log in, there's another RJ45 port for that. Down here in the lower left-hand corner, we have the on-off switch. We have the black button is the door open or close switch, and then the red reset button is a multi-function button. It operates the same as the CS40, if you're familiar with that. You gently tap it once, and it will mute any audible alarms. You press and hold it for about 5 seconds, and it does a reset. Keeps all the settings. It just like reboots it. And if you hold it for about 10 to 12 seconds, it will do a factory reset and wipe everything out, if that's what it comes to. And what you see there with the coax cable jumpers, that's our downlink and uplink signals that would go to a fiber DAS unit if we decide to configure this thing as a master. More on those connections in a little bit. As far as electrical, it is 12 volts, which is a little unusual. Almost all the other BDAs that I can think of are 24 volts, but this one is 12 volts. And it's 12 volts DC. This thing does not operate off of AC at all. The AC goes to the battery backup unit, which converts it to that 12 volts of DC. Maximum power consumption, full load, uplink and downlink is 123 watts. And there's the operating temperature, -30 to +50 Celsius. As far as RF specifications, this is a 700-800 dual band unit. There is no license upgrades. It comes completely configured as dual band Class A. Downlink frequencies are 769 to 776 in the 700 band and 851 to 869 in the 800 band. And there you can see the associated uplink frequencies. Please notice that FirstNet band 14 from the downlink perspective goes from 758 to 768. So that is not passed through the duplexer. This unit does not do FirstNet, and it does its very best to try to block FirstNet. That seems to be what the world wants, is FirstNet seems to be causing more problems than it's fixing as far as BDAs are concerned. So let's just block it and get rid of those problems. As far as the donor and service ports, we do a VisWAR / return loss measurements. So that is done automatically. Some more RF specifications. This is 2.5 watts per band of downlink power, which is 34 dBm. And that's 34 dBm at a maximum, but we can have a 30 dB range and go all the way down to 4 dBm and 1 dB steps. The uplink power is 27 dBm or a ½ watt per band. And once again, that's adjustable for a 30 dB range down to -3 to +27 dBm and 1 dB steps. Downlink gain, we have 90 dB at the most, and we can go down to 60 dB and 1 dB steps. And uplink gain, 80 dB. And once again, another 30 dB range, so we can go from 50 to 80 dB of uplink gain and 1 dB steps. One of the really nice things about this BDA, along with its size and weight, is how many filters there are. I have 96 filter pairs, and by a filter pair, I mean uplink and downlink. I'm considering just one pair. And it's not like half go to 700 and half go to 800. We can assign how many filter pairs per band as long as it's in groups of 8. And we can assign up to 80 filter pairs per band. So let's take a look at this. So band 1, we could have up to 16 filters in band 1 and have up to that maximum of 80 in band 2. And then from there, we can go in increments of 8. For example, we could split band 1 to have 48 filters and band 2 have 48 filters. Or we can put all 80 filters in band 1 and then have the remaining 16 in band 2. So as long as we configure in groups of 8, all the remaining ones are available in the other band. When you go to commission this, we have 3 operating modes. We have Class A, where we have a 12.5 kilohertz wide passband, or a 50 or a 75 kilohertz band. We have a Class B mode, where it's 150 kilohertz wide. And then we have a wide band mode, which covers the entire frequency band, either the 700 or the 800. We bypass the DSP circuitry, so it's very fast, but it will cover the whole band. More features is it has very fast AGC and squelch response time. So this is very important for any network that is P25 phase 2. P25 phase 2 is time division multiple access, meaning one frequency is used for 2 conversations. One conversation is active for about 28 milliseconds. Then nothing happens for 1 millisecond, and then the second conversation comes up for 28 milliseconds, and then it just repeats that back and forth. And what's important is that a BDA can change its squelch and AGC levels within that 1 millisecond space between the 2 conversations. If one, from an uplink perspective, if there's one handset that's close to an antenna and another portable that's far away from the antenna, one's going to need a lot of gain, one's going to need minimum gain. We want to switch really fast between those 2 levels, and this unit can do that. We have an AGC dynamic range of 6 dB. Don't confuse that with the setting. What that means is that a signal comes in that wants to overdrive the output more than its maximum amount. We can knock it down up to 60 dB and still keep our output level where it needs to be. And with a recent firmware upgrade to the 0.5 watt version, and also shipping with the 2.5 watt version, is a firmware version with an automatic uplink amplifier shutoff feature. And how this feature works is after 1 hour, if there's no uplink signals breaking squelch, the uplink amplifier will shut off. And when that thing shuts off, there is no noise coming out of that donor antenna. No chance of any interference, no chance of noise, no chance of oscillation. There's no chance of anything happening when that uplink amplifier is off. And then if a first responder gets close to the building and they break uplink squelch, the thing turns on pretty much immediately, and it's like the best of every world. And this is definitely a requirement up in PCERN, up in the Seattle area. They're the ones who have initiated making it mandatory there. Yeah, and so if you want to install a BDA up in PCERN, it needs to have that feature. So be sure that both CS45s, the 0.5 watt and the 2.5, do have that feature. And honestly, it's a good feature to have everywhere. Speaking of uplink squelch, we do have that. It's adjustable from -100 dBm up to -70 dBm. We also have a feature we call dynamic AGC. You can turn that on or off. And this is best described with showing you a scenario. So this is with dynamic AGC on. And what dynamic AGC on or off determines is how much power per channel will be available on different circumstances. So when dynamic AGC is on, and we have 4 filters programmed. So this scenario is with 4 filters. If of those 4 filters, only one of them is seeing an active channel, that filter can get full power. Now, if 2 of the filters are seeing a signal above squelch, they're going to take the full power and divide it in half, or 3 dB down, and one of the filters will be able to put out maximum power minus 3 dB, and the other one will as well, or half power. And it keeps going like that. If 3 of the 4 filters see an active signal, then they each get a third of the power. And then finally, if the 4 filters, all of them are seeing active power, then they're going to divide the total power by 4, and they'll each get a quarter. So that's what we mean by dynamic. How much output power will each filter have on its output? It dynamically changes depending on how many filters are seeing a signal. Now, if we turn dynamic AGC off, then it's not dynamic. It doesn't matter how many filters are seeing a signal, or even if only 1 or 2 or 3 or 4. If one of them sees a signal, it gets a quarter power. If 2 of them sees a signal, they still get a quarter power. They'll always have a quarter of power. So it's very steady power. It's not changing. It's very predictable what the output will be. Always a quarter of the maximum amount. We make this a feature that you can turn on or off. I'm not going to say one scenario is always better than the other, but it's up to each installation of which one you want to do. Now, even though we do have a front panel annunciator, often you do need to have a remote alarm annunciator. And this one connects right up to the unit the same way that the CS40 does, if you're familiar with that. It's that's part number. It gets connected to the CS45 through a Cat5 or Cat6 cable using RJ45 ports. It's not power over Ethernet. It's RS485. And using that Cat5 or Cat6 cable, you can have a distance of up to 3,000 feet away from the CS45. Now, when it does come to commissioning, we have a graphical user interface and kind of built into the unit. There's no special software needed. All you need to do is hook your computer up through an Ethernet port and a Cat5, Cat6 cable. Open up your internet browser to 192.168.150.1, or excuse me, .1.150, and you're going to be in. It's dynamic IP addressing. You don't have to go through static or manual mode. It's ready to go. In fact, it's so simple. I've hooked up a smartphone, both iPhone and Androids, with a USB-C to Ethernet adapter, plugged it in, and really all I had to do was turn off the Wi-Fi and put it in airplane mode, and then you can commission the CS45 and the CS40 from your smartphone if you really had to. Very easy to use. It uses the same graphical user interface as the CS40 and the half-watt BDA. So I just have a couple of screenshots here just to show you how easy it is, even if you've never seen it before. This is what you would see when you first log in. These are the different areas that you can go to. The area in the green, that would be the alarms. And then we have the RF configuration, system settings, alarm testing, SNMP traps for remote monitoring. And then we have backup and restore configuration, which can store the BDA's configuration. And you can restore that configuration to another CS45. So if you're installing one of these in, let's say, a particular jurisdiction, you get all the frequencies and the bandwidths and everything all set up. When you do a second project in that same jurisdiction, rather than starting from scratch, you can take the backup configuration from project number 1, restore it into project number 2, and you're still going to have some settings to set, but all those filters are going to be already programmed for you, which is pretty nice. If you clicked on that alarm area, this is what you would see. It's very clear cut. I think almost everybody here would understand that if there's an alarm mentioned like AC power and it's surrounded in green, it means we're good to go. If it's surrounded in yellow, it means there's like a warning, like the door's open, but it's not really affecting any RF performance. And I don't show it here, but if one of these alarms was in red, that's pretty serious. That's something you definitely want to look at. And then the one in white with the word struck out, that's an unmasked alarm. So from the factory, the remote annunciator communication alarm is masked because it's assuming you don't have one. But if you did connect a remote annunciator up, you definitely want to unmask that alarm so you could see if there's ever any problems with it. This is the RF configuration page. You can see you can turn on the filters there. So I have filters 1 through 8 on, but up here in this area right here, we have 19 filters activated. And we would just need to go down to here to see what filters 9 through 16 are and all the other ones. We have a downlink and uplink gain. Here's our uplink squelch. Here's AGC level. This is the output power. For downlink and uplink, high-powered amplifiers turned on or off. Here's the VisWAR return loss. We do measure isolation automatically by just pressing this isolation test button. And here we can toggle between the 700 and the 800 bands. And down here in the mode, this is where we would select Class A, Class B, or that wideband mode. Moving on to the battery backup unit, this is the CS19-BBU-005. And as I mentioned at the beginning, this is unique to the 2.5 watt BDA. It is not used for any other product. This BBU does have the battery charger within it. Pretty much we have two sides to this BBU. The side over here on the left, which we call the sidecar. This is where the battery charger is, and all the cable assemblies are connected to that charger. And that's also where the AC goes in. It gets converted to DC. And the right-hand side, the larger of the two cabinets, that's where the battery goes in. So all the normal battery backup unit alarms are generated within the BBU. So no AC, battery charger fail, battery capacity less than 30%. They're all generated within the BBU. And so we're going to need to route those alarms up to the BDA so they can be enunciated on its front panel alarm enunciator. So we'll show that here in a minute. It is 12 volts DC, so really only one battery is needed. But here it says 1 or 2 batteries. And what the difference is if you put one battery in, which is this model number right down here, this is a 145 amp hour battery. So it's a pretty good sized battery. It's going to last for 12 hours. But if you put 2 of these batteries in, and again, they're the same model number, so 2 identical batteries in, and wire them in parallel, not series, but in parallel, so we still have the 12 volts, then the 2 batteries together will last the 24 hours. And here's just a quick diagram of the BBU. You can see that the over on the sidecar area, the front panel does not have a hinge. It just comes straight on and off, which is kind of nice. And then the dimensions there are shown there. I won't read those. The battery backup unit comes with 2 cables. One cable is to supply the 12 volts. It comes with a connector, 4-pin connector on it. And then the alarms that I mentioned comes with another cable, and it has 6 pins. And again, those connectors are already on the unit. So you just send those connectors through the 3/4 inch conduit, run it up to the BDA, and run it through its 3/4 inch conduit, and just click them in. That's all it requires, just stick and click. And I went and measured that cable from one conduit port to the other conduit port is about 10 feet long. So that's the BDA kind of by itself, but as mentioned, it can be turned into a fiber DAS master. So let's see how we do that. And by the way, we just introduced a new platform for the fiber DAS master, or the fiber DAS system. We call it version 2. And this new version 2 not only works with the 2.5 watt CS45 700 800 BDA, but it also works for CS40 UHF and VHF mid-power BDAs. We're going to have some webinars on those new units this month and in March. So keep your eye out for those webinars to explain how the CS40 UHF and VHF will work with this exact same fiber DAS system I'm going to show you now. We're still ironing out the final details as far as the CS45 2.5 watt BDA. It's once we get that firmware nailed down, we think that it's going to be available sometime this quarter. We'll just say maybe in February, maybe in March. So before I get to the details of that fiber DAS system, let's just make sure we understand why we'd want one rather than just a BDA. And one scenario for that is just really, really large buildings with a lot of square footage. You know, a BDA only has so much power, and every time you add an antenna, it sucks a little bit of that power away. And once you add too many antennas, there's just not enough power left. And rather than putting multiple BDAs into a very large venue, it's way better to put in a fiber DAS system. And the other scenario where you want fiber DAS is a campus setting with multiple buildings, all of them needing a enhanced coverage. Instead of putting a BDA into each one of these 4 buildings shown, you put a single fiber DAS system. And it's going to be much easier to run and much easier to commission. And the reason that we don't really want to put multiple BDAs close to one another is when you have all these donor antennas, which may be facing into each other, or the donor antennas facing straight into the building right across the street, we can have oscillation issues. We can have timing issues if both BDAs try to transmit the same signal. And we're definitely going to have more uplink noise the more BDAs that are in a tight area. So multiple BDAs, not a good idea if they're really close together. Fiber DAS is the way to go. So what is our new fiber DAS platform? You're looking at it here. It consists of 2 components. We have the HE and the RE. The HE, which stands for head end. This is going to be mounted next to the master, the BDA, so next to the CS45 2.5 watt version. And then the remote end, that's going to be connected to the remote amplifier in, let's say, each of those individual buildings. I'm showing you the inside of each of these units. If the front panels would be on, you would see that they have an annunciator on them, an alarm annunciator. So the head end will show the alarms of the master and also the fiber, whether the fiber is good or not. And on the remote end, it will show you the alarms of the remote and also if that single fiber is working or not. To connect that head end to the remote end, you're going to need a single mode fiber. So single mode is typically yellow jacket like you see there. It's not a law, but most of the time it is yellow. And then we need the connectors SC APC. Those green connectors you're looking at, that's what an SC APC connector is. The green represents the APC, which is the angled physical connector. The actual fiber itself, the glass, has an angle on it, which reduces reflections. It's very, very important that we have little reflections in this system. It's an analog system. They do not like reflections, and so everything needs to be angled. The specifications for that fiber run is we can have 5 dB of optical link budget, so no more than 5 dB of optical loss from one end to the other. And as far as that reflectivity, whatever power goes in, when it gets bounced back, it should be at least 60 dB lower. And you're going to measure that with your OTDR, your optical time domain reflectometer. And it is really important that everything is angled. Everything has to be APC. So if there is a patch panel that you're trying to use and that patch panel is blue or gray, it's probably flat. It should be green. And if you want to use a patch panel, but it's the wrong type, splice them together. Just don't use it. So this is how everything gets connected. So here's our CS45 2.5 watt BDA connected up to its battery backup unit. The red and the black wires represent the 12 volts. And then we're going to make 3 connections from the CS45. The blue line represents a Cat5, Cat6 cable. That's going to send data back and forth between the master and the rest of the system. And then the 2 gray lines, that represents a downlink and uplink jumper cable. It's SMA to SMA. That's included with the units. And then the units, the HE and the RE, do not have any power supply, so we need to supply power to that. So 12 volts will leave the CS45 and connect up to the HE unit, the head end unit. So those are the 3 connections between the master and the head end: data, RF jumpers, and voltage. From the head end, we can have up to 4 fibers. So 4 of those single mode SC-APC connectors. And they are not going to connect to the remote. They are actually going to connect to the remote end, the RE. And the RE is going to convert that light back into RF. And once it converts it back to RF, we're going to have the same 3 connections that we saw before going to the remotes. So the remotes are going to get the Cat5 cable for data, the 2 gray wires for the SMA connectors, uplink and downlink, and then the plus 12 volts. And then each remote is going to be powered by its own battery backup unit, which we see there. And that remote, by the way, is a different part number. It's a dedicated remote. It only has a service antenna output. It does not have a donor antenna output. It does not have uplink amplification. Uplink goes through the SMA connection and then through the light. Now, some of you might be thinking, well, that's great if all you need is up to 4 remotes, but what if you need more than 4 remotes? Well, we got you covered there. So here's a simplified diagram of what I just showed you. 1 master connected up to 1 head end unit, connected up to 4 remote end units, and that is connected up to 4 remotes. And what we can do is we can daisy chain head end units. We can daisy chain up to 3 more. So we can have up to 4 head end units, and each head end unit can have up to 4 remote end units, which means overall we can have 16 remotes if fully built out. Now the HEs have the connections to daisy chain the Cat5 cable and the 12 volts, but the SMA connections, there are no, we'll say, pass-through for that. That has to be done externally. So right here, for example, in this particular setup, this could be a 4-way splitter for downlink, a 4-way splitter for uplink, and then each of the 4 outputs would go to each of the 4 HE units. Here are the kits. Again, this is a single part number. So for example, here's the part number for just the BDA. But if you wanted a kit that included the battery backup unit and a 12-hour battery, you can just order the K1. And if you had a 24-hour need, you can order the K2. And what happens is that the BDA, the BBU, and the batteries all get shipped on 1 pallet. So 1 order and 1 shipment makes it very easy. The BBU and the BDA have 3-year warranty covered by Westell. The batteries, Westell does not warranty the batteries, but the battery manufacturer does. And the battery manufacturer is for 5 years. But kind of like when you buy tires, there's a whole bunch of disclaimers. There's a bunch of disclaimers for the batteries, but take a look at that and see what's covered and what's not. And that ends my presentation.